So for A, to find the equation of a function, we first must look and find what the points within the problem are. So to do this, we can look at the problem. It says we have a low point. We have a low point at negative 200 when x equals 22.5. Then it also gives us a high point. A high point being at negative 150, where the x is at 24.8. So we can use all these numbers to create a coordinate point and another coordinate point for the high point. So we take the x value, the 22.5, and we put it in for the x, and we take the low point, which is the y, and put it in for the y value. And then we do the same for these numbers as well. Now that we have these 2 points, we can now create a graph, a sinusoidal graph for the equation. Okay, wait. Now that we have these 2 points, we're able to create a sinusoidal graph. If you've done these problems enough not to create the graph, I recommend you not. But if you're just starting at these, then create a graph to help you see what's going on in the equation. So start off with the graph. We draw our axes. We have our y and our x axes. Notice how these axes, the x-axis is higher compared to the y than it usually is, and that's because the high point is at negative 150. So we're going to have no values that are no y values that are positive. So most of our graph is going to be below the x-axis. So then we label the low and the high points of the graph. So we have negative 200, which is right here, and we have negative 150, which is up here. Next, we put down our x values, so 22.5 and 24.8. And then we graph the points. So right here we have 22.5 and negative 200. So we'll put that there. And we'll put the negative 150 and 24.8 up here. So we're going to have a graph that roughly looks like that. But just to help me see it, I'm going to put another dot out here, approximately where it will be next, that next low point, and connect it to the high point. So there's our graph. Now we can finally write the equation of the function. In order to do that, we know it's an equation, so we'll have a y equals out here. So we'll have a y equals out here. Now, for whenever we're doing a sinusoidal function, we always want to use cosine, never sine. It's much easier to create an equation with cosine, so that's what we'll stick with for now. So we'll know we'll have a cosine function in here. It'll be cosine of x of something. Then we'll have a term right here, and right here. This term will be the multiplier. This is what's being multiplied inside the cosine, and this is the number that is added or subtracted to the end of the equation. To find this end term, what we need to do is we need to average the y values from each point, so from the high point and the low point. So in order to do that, all we have to do is do negative 200 plus negative 150, which is the same thing as saying minus 150, of course, and that gives us negative 350. Divide that by 2, and you get negative 175. So that is what we're going to put as our end term right here, minus 175. I'm doing it in order of difficulty, that's why we're going left to right. But Now for the multiplier, what we'll do is we have to find the difference between this term, this middle term, which is around here, correct? And find the difference between this term and that term, or this term and this term. So we have negative 175, and how many numbers is it away from 200, or from negative 200? To figure that out, all we have to do is add 175 to 200. So, or negative one, we have to add 175 to negative 200. So, 200 or negative 200 plus 175. That gives us negative 25. So that will give us our multiplier, negative 25. The next term we'll find is the term within these parentheses. This term right here will be the x value of the point closest to 0. So our x value is 22.5, so we'll input it here. But remember, whenever we have this in here, we have to make it x minus 22.5, or if it's negative, plus that number. Finally, we have to find the term right here. This term will be 2 pi over the distance from here to here times 2. So to do that, all you do is take your calculator, take the point right here, 22, or take the highest point, 24.8, subtract 22.5, take that number, because that number is the length from here to here, and then multiply it by 2. And that gives you 4.6. Now that we're done writing, alright, now that we're done with A, let's get on to B. So, in the B, we have to be very particular about our directions and reading them, because, for example, in the very first 4 words, it says find the first interval, and that is one of your biggest directions, because you are either finding an interval or you're finding a time. A time is a point, and an interval is 2 points, and the points in between those 2 points. So when you're reading the directions, be very careful of that. Next, we have to find the y value of negative 180. So we have to find all of the points on the graph that are less than or equal to the y value of negative 180. Lastly, we need to find those sections of negative 180 right after x is equal to 0. So we're going to begin by setting negative 180 equal to our original equation, because we need to find the x values of the y values on the graph of negative 180. So we're going to do negative 180. Negative 180 is equal to negative 25 cosine 2 pi over 4.6, open parenthesis, x minus 22.5 minus 175. So from here, let's just get out our calculator and start crunching some numbers. So we're going to do negative 180 plus 175, enter, and then we're going to divide by negative 25. Whoops, that should be a negative. Next, we need to next we need to inverse cosine, so second cosine of the answer. So, and the answer would be 0.2, so that gives us that wonky number. Now we multiply it by 4.6. Now divide by 2. Now you gotta do second answer, divide by 2, divide by pi, and lastly we need to add 22.5, so plus 22.5. So that gives us that number right there, which is one of our interval points. So we can write that down real fast. So 23.503. So now that we have that point, which is approximately right here on the graph, probably around here, given that this right here is negative 180, we need to find our next point, because an interval is between 2 points, or it has a beginning and an end. So how are we going to find that point? Well, the directions tell us. So if the function is less than, or equal to negative 180, so we're finding all of the points beneath 180. So we're finding all of these guys right in here. So right here, we need to find this point right here to complete this interval. How we're going to do that is we're going to take 22.5, because we know this is 22.5, and this, which is 23.503, and we're going to subtract 22.5 from 23.503. That will give us this distance right here. After that, we're going to multiply this number that we got by 2, because this distance and this distance must be the same. Let's calculate it on the calculator. We're going to do this number, 23.503, enter, subtract 22.5, click enter. So that's going to give us 1.003, and we're going to multiply that number by 2. And that will give us the distance from here to here on the graph. So let's write that number down really fast, because it's nice to keep note of all of our numbers. 2.005. So now that we have that number, we can find this point right here by simply subtracting what our original point was, which is 23.503, minus this right here, and we're going to get 21.497. So 21.497 to 23.503 is one of our intervals. Not the one interval we need, but an interval that will help us a lot. All right, we are approaching the end on B, and now what we are going to do is actually figure out why and how we are going to get the interval closest to 0. So our goal right now is to get this interval right here to the interval all the way to 0, which is that way. So if you could imagine the graph going on forever, there would be a point here and a point here, and this would be an interval as well, just greater than 23.503 and 21.497. But because our graph isn't proportional, I can't show you to the left at all. But what we're going to do is actually, because we know that for the distance from here to here is 4.6, given our rules about waves and what we found out before, if we were to subtract 4.6 from 23.503, we would be able to find the point corresponding to the wave behind it. So what we're going to do is actually find, so we're going to have this number, we're going to subtract 4.6. Subtracting 4.6 will give us the point corresponding on the wave behind it. It's probably around there somewhere. And then, if we click enter, it's going to give us some number, 18.902. Now, I'm going to write down all the numbers we get, but it's not necessary, but it's a nice visual to keep your lists and intervals in check. So I'm going to actually click minus, and that'll automatically give answer minus, and then you're going to say minus 4.6. And if you keep clicking enter, it will bring you all the way down to a number either really close to 0 or past 0. So these numbers right here are all points of negative 180 on the graph. So I'm going to write them down, and you will see why in a second, but it helps, writing down the points, especially in the beginning, helps keep your numbers in check, or your intervals in check, and it'll reduce the chance of you messing up or whoever is writing it messing up. So let me finish writing these out here. 03, 5.103, and 0.503. So now that we have that, we do the exact same thing for the other point on the intervals. So let's go up and grab that point real fast, which is right there. And we're going to hit minus 4.6, and that will be 16.897. So this right here will be another interval. So this is one interval, and this is two intervals, or another interval. And then again, I'm going to do answer minus 4.6, and we're going to go enter, 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 enter. Oh, and we went past 0, so that's going to be, those negative numbers probably won't come in handy at all. Now, let me just finish out writing these intervals. All right, we come to a dilemma here. So this last interval is very weird because we have one of the points above the x value of 0, but we have another point before x equals 0. So to put it in a graphing form, the graph would look like this. The graph would be this is the x-axis, y-axis. The negative 180 would be right here, and we would have part of the actual graph coming out, but only part of it's actually after x equals 0. So right here's the cutoff. So this is in, but this is out of the interval. So only part of the interval is in. And what we do in a situation is we actually disregard the rule of the entire interval having to be inside the given area or after x is equal to 0. So what we do is we say 0 to 0.503. So the entire interval doesn't have to be in the given area, but only part of it does. So in this case, our answer for B would be 0 to 0.503. All right, now to C. So the difference between C and B, again, as I said, was the interval and the time. So the time is actually a point on the graph rather than an entire interval. And it's actually going to be after the x value of 50. So we have to find the first point on the graph after x equals 50. So the closest one to 50, but after 50. So in this case, it actually gives us the same y value that we need in C as we did in B. So we can use the previous problem and use the points from the previous problem to help us do this problem, which is actually really nice. So I'm going to go right here. So 23.503, that's this number. So instead of subtracting 4.6, I'm going to be adding 4.6 a bunch of times because that'll give us corresponding points on other waves or wavelengths. And it'll give us just corresponding points. So I'm going to add 4.6 once more. And I'm going to add 4.6. Enter, 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 enter. And we're going to do the same thing with 50. So the moment it goes above 50, I'm going to write down that value. So 51.103. Now you're probably thinking, oh, we're done. But we actually aren't, because there's a chance that this point right here has a closer value to 50 that is greater than 50. So we need to actually use this point as well to make sure that this isn't the closest value to 50 on the graph that's greater than 50. So we're going to actually take this right here, and we're just going to change this to addition. And we're going to just click enter. Again, answer 4.6. Enter, 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 enter. Oh, and this is 53.697. Now, fortunately, our first point was correct, which was 51.103. That's the closest, but greater than 50. But you always got to double check those 2 points. Otherwise, there's chance that the other point might have a value closer to 50.